Just a little bit about your background to get started. Where did you get your undergrad degree and advanced degrees?
I did my undergraduate degree in psychology and linguistics at the University of Pennsylvania in Philadelphia. And then I did a one-year fellowship at University College London, where I got my master's in language science. And then I came back to the States and enrolled in the Harvard and MIT joint program in speech and hearing bioscience and technology, where I got my PhD along with my clinical certificate in speech language pathology in a dual track clinical practice with research.
Tell me what age you like to concentrate on and what's your specific area of research.
I love working with kids of all ages. Clinically, I really enjoy working with infants and very young children, toddlers, preschoolers. Scientifically, I tend to work with more school age, preschool and early elementary school, up through adolescence, just because brain research is typically very difficult with infants. We have researchers here who do it. I tend to specialize a little bit more in the school age.
You and your colleagues had a hypothesis. What specifically were you hoping to determine?
I was really interested in how children's language environments, so the words that they hear growing up all through their childhood, how this contributes to their language development and their brain development. And we know that to develop language, you have to hear language and experience it. And so we had a hypothesis that there's a neural relationship between this input and output. And we wanted to see whether it corresponded to traditional brain areas, to maybe non-traditional brain areas in ways that we didn't expect. And we wanted to see how this related to individual differences in the amount and quantity and quality of language that children hear. And specifically how this related to socioeconomic status, or how one relates to the wealth and education in their circumstances. And so we brought in a bunch of 4 to 6 year old children in the preschool age range, along with their parents. We had them do some standardized assessments. We had them do a brain scan where we could look at both the structure and the functioning of their brain, their function while they're listening to speech and actually processing language. And then we sent them home with little language recorders that they wore from the time they woke up in the morning to the time they went to bed, and it recorded everything they heard and said for 2 full days. And then we crunched the numbers, ran it through some algorithms, and were able to estimate how much language these children were actually hearing in their real day-to-day environment. And then we were able to relate that in turn to their brain structure function and then to their language development.
How many sets of kids and parents did you work with?
We recruited a total of 83 families with children ages 4 to 6. And we worked with almost all of them in the scanner. We have a few that not every child is super excited to go in an MRI, so our final sample ended up being a little smaller than that, but in some we had 83 families.
Can you describe for me what you and your colleagues saw when you looked at the scans?
With MRI, or magnetic resonance imaging, we can look at a number of different things within the brain. We were interested specifically in the functioning of language regions in the brain. So in your left hemisphere, you have a couple of language regions, one in the frontal lobe, sort of right above your temple, and then one sort of in the back behind your ear in the temporal lobe. And the two communicate with each other, and they process language, and then they form the language that you then produce when you're speaking. And so we wanted to see how these language regions were activated when children were listening to simple stories. So we had them listen to a bunch of simple stories, about 5 minutes worth, and then some speech played backwards so that it sounds like speech, but it doesn't mean anything. So we can really get at the heart of understanding and meaning when we compare those two things. And we were able to see that the amount of conversations that children have with adults, so not just the number of words that they hear, but the amount of back and forth conversation related to the brain activation in that frontal speech region while they were listening to the language.
What does that suggest?
It suggests to us that there's more to than just listening to language, that it's an interactive communicative process, that children need this sort of back and forth conversation, taking turns. We call it conversational turn taking, and that this is really what supports language and the development of these brain regions that support language and higher cognitive functioning as well.
I know in the past there's been a focus on 30,000 words and numbers of words your child will hear or should know or recognize by a certain age. Was that a part of the study?
There has been a lot of focus within the last couple of decades on the quote-unquote 30 million word gap, which is, from this incredible groundbreaking study that found that children from more well-off homes were hearing on average 30 million more words than less advantaged children by the time they got to school age. And it's really just an incredible set of research. And so we wanted to first see if we could replicate that and see if we could see these individual differences between children in the amount of words they heard, but also see if it's not just the amount of words they heard that is important for development. And so we did see that there were differences between families in the sheer quantity of language that children were hearing. Some were hearing lots and lots of talk, some were hearing very little. Some were hearing 10,000 words a day, others were hearing, 1,000 words a day. Big, stark differences. But it wasn't the differences in the number of words they heard that seemed to be most strongly linked to brain development and cognition. It really seemed to be the amount of conversation. Even when we control for the amount of words that they heard, it really seemed to be the amount of conversation that drove brain development and cognitive development.
For example, just putting a child in front of a television program is not going to have the same effect as that interaction with a parent or caregiver.
It's a bit of an extrapolation on our parts. We didn't test directly whether robot words compared to human words, but based on our results, we can assume that it's the back and forth. It's that communicative, listening to someone, formulating an answer, responding, asking questions, probing, and truly listening and communicating human to human that we think is really important for the development of these brain regions.
There was a socioeconomic part to your research. Can you speak to that a little bit?
Socioeconomic status in our country is so strongly linked to child development, developmental outcomes, and in the last several years we've discovered that it's strongly linked to brain development, brain maturation of critical components that have to deal with cognitive skills. And so one of our goals was to see how language exposure related to socioeconomic status and brain development in sort of this triad of relationships. And what we were able to find is that while SES is related to language development and it is related to the amount of language you hear, the conversational back and forth outweighed socioeconomic status in predicting both brain development and cognitive development. So you can be a low-income family and hear lots and lots of conversation, and your brain development will be right on par with a higher-income family.
What takeaways can parents get from this research?
From our point of view, we think that this suggests to us that conversation is really a driver of brain development. Interactive language with children, starting from even when they're very young, even before they're not overtly responding to you, you can have these turn-taking experiences. You can make faces and blow raspberries with infants. You can ask toddlers questions about their day. And as they get a little bit older, you can start to have more in-depth conversations about a number of different things. So turn-taking takes different forms throughout a child's development, but we think this fundamental act of turn-taking of language back and forth is what really drives development.
You had mentioned you can start from birth with faces. Is there a particular age where it's most crucial?
We know that language development is critical in the early years. So in the 0 to 3, maybe 0 to 5 age range is when children are like sponges. They're hearing everything that goes around them, they're soaking it up, and it's driving their brain development. We know that their brains are developing millions upon millions of synapses. Their neurons in their brain are connecting to each other and forming circuits. So the early years are the most important for these types of experiences that are going to be important for brain development. Some more recent research suggests that really in the first 2 years of life is even the most important, specifically for language. But that doesn't mean that, a child's fully formed at 3 or 4 and you can stop either. So we know that this is a snowball effect. It builds. So, if you build a strong language foundation earlier, then you can continue to build on it later.
Why is it so critically important for children to have these skills?
Language and communication is crucial for us as a human species. It is how we communicate with others. It's how we communicate our wants and desires, our feelings. It's been crucial to the development of humans throughout civilization and throughout time. And so it's seated in this part of the brain that is really, really important for our success. And so from an evolutionary standpoint, language is very important. From a standpoint of a modern human, it's very important for success in academics. When we're reading texts, it's crucial to understand the language that you're reading. It's how we communicate with others. Think of how many emails you send every day. That's all language, Even if you're just sending an emoji, you're sending a thought that is communicated through some form of language. And it's even after childhood, it's crucial for success in our world today, communicating with others who are like you, unlike you, and communicating thoughts of all kinds.
I know that you were speaking to the lower socioeconomic sample. Was this in English or Spanish? Did you look at the difference between families who speak both languages, or was it monolingual?
For our study, families needed to speak English as a primary language in order to participate, but about half of our participants, both on the higher and lower socioeconomic side, spoke more than one language, often Spanish, many European languages, and many East Asian languages as well. And what we found is that the power of conversation cut across bilingualism or monolingualism. It's just as important no matter which language you speak or how many languages you speak.
Next steps for your research?
Our newest research project is to take the next step, now that we know that conversation is so powerful for brain development, to actually do a longitudinal study where we're looking at if we can increase the amount of conversation that families have, do a short interactive intervention program with families and children and increase the amount of conversation that children hear. Do we then see the brain changes down the line where we see that accelerated brain growth and commensurate language skills? And our initial look suggests that it's going to work out.
Is there anything I didn't ask you that you would want to make sure that people know?
I guess I would want people to know that brain science is actually a really incredible tool. We're using it to gain insight into a number of different aspects of child development. And this is driving some really, really important discoveries, but also changes to policy, to education, to the way things function in our society. While it's cool to see brain pictures and read these results, they are actually important for driving our society forward. And I think it's just a really special time to be a part of this field.